Okay, so here we're going to look at relationships between predators and prey, and really more focusing on how that's going to potentially impact management decisions, and how are we going to either use these relationships to manage, how do we have to accommodate these relationships in managing, those sorts of issues. But in order to really understand that, obviously we need to know a little bit about how predators operate, about the sorts of interactions we expect them to have with prey species, that kind of stuff. So with that in mind, then, turns out that a lot of animals will eat meat if given the opportunity. Okay, lots and lots of what we'll call opportunistic predators. Now, this can include omnivorous animals. We get down to things like bears. Bears will eat meat if they have the chance. Down to things like possum. Possum will eat meat if it has the option. Possum will eat anything, right? Beyond that, even some things that we think about as being typically herbivorous, right? Things like deer. There are certainly places where we can see, so for example, the Isle of Skye, off the coast of Scotland, the red deer there regularly hunt and kill mice. So lots of flexibility, right, in terms of how animals tend to operate. Just to keep things simple, keep things as clear as we possibly can for right now, we're going to focus on mammals here in carnivora. So this be including things like dogs, cats, their relatives, stuff like that. And then also with birds, raptors. These are hawks, eagles, stuff like that. Historically, right, we've always considered predators as in the context of game species, right? We only ever thought of them as kind of holding down the numbers of population sizes for things that we might want to hunt, right? And because of that idea based around kind of thinking what predators were, predator control was really, really common. And we've talked about how predator control was often kind of the only management option really considered for a lot of things. And really, beginning in the 1930s, when a lot of this science really started to take off anyway, it was not much else thought about, right? They were just kind of nuisance species is the wrong word, but certainly not considered outside of the notion that if we got rid of all of them, we'd have a lot more things to hunt, right? Going back, to our friend Aldo Leopold, he was really one of, if not the first person to think about density dependence, right? Some of these ideas that we've talked about before, that different things are important at different population sizes and different population densities, right? And part of that work for him ended up kind of being an understanding that the role of predators in prey or game species population management changes depending on a number of different factors, right? And so really, when we think about predators, we think about what their impacts are going to be on the species we're trying to manage, or other species if we're trying to manage for the predator, right? Things like the density of prey, right? How many prey animals per square meter are there? Obviously, the higher that is, the easier life is for predators. The density of the predators themselves, right? So this is competition. Okay, the more predators there are in a small area, the more competition for food, the greater the resources required are going to be. Food preference. A predator could eat just about anything it can hunt and kill, but it's going to prefer certain things that are easier maybe to kill or have a greater return on investment, right? The effort they put into it, they get a bigger reward for hunting one thing maybe than for hunting another. The overall health, right, of our prey. We've been talking about various things that can get into, say, body condition of prey. The quality of prey kind of goes both ways, right? It's easier to hunt a sick or dying animal but it's maybe not the best food choice for you, right? So that kind of comes into play here a little bit also. And then of course, if whatever we would prefer is rare or unavailable, what are our other options, right? And one thing that we'll see a lot is that a predator might have a preferred food choice, but as it hunts that population down, it will often switch to other prey who are more abundant, maybe easier to catch and to kill. One of the early ideas, and this is kind of not really historically borne itself out, but a guy named Arrington, one of the early guys to work on this stuff, had this idea that predation was really only something that was an issue when prey populations were already above carrying capacity, right? And that is kind of a backward way of thinking about it, right? Because predation is a part of what K ends up being, right? The capacity to survive and to not be eaten or otherwise die is what K is, right? So it's kind of a wrong-headed approach to that. When we think about mortality in general, what kills animals, we can think about compensatory and or additive mortality. For animals above carrying capacity, right, the idea is that those animals are probably going to die, right? The surplus population, so to speak, right? And so it doesn't matter if those animals die of starvation or if those animals are killed and eaten, they're going to die anyway, right? And so those animals that fall out under those conditions, right, that's compensatory mortality, right? They were going to die from one thing or the other, doesn't really matter, okay? Additive mortality is animals that die beyond kind of the natural expectation, right? So if carrying capacity is 50, you've got 75 animals in your herd, 25 of those are going to die no matter what, okay? If they die of starvation, they die being hunted, okay, whatever, that's compensatory. If 35 animals die, right, those additional 10, right, that's additive mortality. One of the other things that we've thought about, and actually can perhaps be true in certain circumstances, is that we can actually have high predation rates with little effect on that breeding population next year. And the reason for this is maybe intuitive, maybe not, I'm not entirely sure. Basically, the idea is that out of a population, right, typically this is for males, but it can work the other way for females also, only a certain percent of those animals will actually ever breed, right? So if you have 50 bucks, maybe 5 of those actually breed and end up having fawns the next year, right? Which means theoretically, right, you could cull 45 of those 50 bucks and not have actually any impact whatsoever on breeding populations, right? Taking doe is a little bit risky, right? Because probably all or most of those doe will mate the next year. So again, one of the reasons that hunting permits are staged the way they are, right, with more bucks and fewer does is because of that, right? You can take a lot of males without really affecting breeding. And so that lesson, right, that idea that demographics matter has been one of the earliest and really the best kind of identified lessons from a lot of this early work. Now, obviously, because of the way that funding works, right, most of the work that we've done has focused on game species, right? Animals that are economically important in some way. More recently, starting in the 70s and kind of moving forward, we've also started to think about threatened and endangered species as well. And because of that kind of approach, kind of the sort of the broader, more holistic scope of things, we've kind of moved away from thinking about just predators or just prey into kind of this whole ecosystem approach, right? all of the animals that might interact, their environment, all of that kind of stuff. And a big part of this, right, not only is because we now understand that all of this is important, but studying predators is actually really difficult and can actually be really expensive to study, right? Don't have a good handle on a lot of excellent ways to kind of study this material. Some of the things that we can do, right? We can look at animals that have been taken, right? Carcasses and things like that. But that only tells us what was actually successfully killed, right? And in a lot of cases, maybe it doesn't tell us what was successfully killed, right? Because we get a lot of carcass scavenging in predators as well. And so it could have been an animal that died of other causes, and it simply has been subsequently scavenged. So not really a lot of great answers on that. And so ultimately, right, success and failure rates of predators in terms of their hunting can be really, really hard to get a handle on. So what are we going to do? What are we going to be able to think about? Well, when we think about predators and we think about their impacts on ecosystems, we have to understand a little bit about the individual animal's behavior, just as we would with game species. And one thing that's interesting about predators is that oftentimes, because of the way that the trophic scale works, right? The fact that the higher up you are in the food chain, the more individuals you have to eat to get the same original calories out of it. Predators tend to be solitary, and they of course they don't have to be, and they tend to have relatively large territories. Okay, in order for them to be able to survive. And so territorial behavior becomes a really important part of understanding predator behavior. And one thing that comes out of that is that a territory might be so large that there might be enough game to support 20 bobcats or whatever, right? But because the territories themselves are so large that there's really only physical space for 5 bobcats, right? And depending on the kind of predator, these territories might be year-round, right? So typically for mammals, we find year-round boundaries for year-round territories. But for hawks and for raptors, those territories tend to blend a little bit most of the year. And it's really only during breeding season where competition for mates is at a premium that we do see real territorial behavior in those large birds. Other things to consider, right? We talked about prey selection before, right? How do they find what they're looking for? What are they're using as their main guides? For birds, we think about sight, we think about sound, right? They have really excellent sight often, good sense of hearing, okay? For mammals, it's sight again, right? But oftentimes, really more so than sight, smell is a major way of prey tracking, okay, and prey location. For reptiles, right, there are certain snakes we call pit vipers. They have Jacobson's pit organs on the front of their faces that are sensitive to infrared light, so they can actually sense body heat. And bats, of course, we're familiar with bats here. They echolocate, right? They use sound to identify their prey in a slightly different way than, let's say, birds do. We also see that different kinds of predators actually get their prey in different ways, right? So we can think about ambush predators. Your cat at home, if you have a pet cat, is an ambush predator, where they will lay in wait and they will make only a final leap out. We also get pursuit predators. Okay, these are going to be things like cheetah, okay, where they will actually run down, or for that matter, wolves will run down their prey. And then we get animals here that are called systematic search predators. And these are typically going to be predators that are looking for small or cryptic or which are well-hidden prey items where they kind of just march their way around and systematically look for, say, bugs in a tree stump or stuff like that. Most predators, like we said before, are solitary when hunting, okay? And most predators are also solitary when not hunting, Okay, but we do get pack animals. There are social predators like wolves, harrises, hawks, obviously lions, things like that, that will hunt in groups, will hunt in packs, and sometimes will live in packs and groups, but most predators tend not to be. The prey that is chosen, they kind of have a very sophisticated arithmetic behind what they're going to try to go out for. And so the animals they pick might be influenced by what other options are out there, right? If you go to a restaurant and there's one food item on the menu, you're stuck with that, right? But if there's 15 different things on the menu, you kind of have your choice as to what you think best suits you at that point in time. And a big part of choosing one prey item or the other, right, if these alternate prey are there, is how many are there, right? If there's a whole ton of these one things, right, you might go for those instead of something that's a little more rare. Even if these guys are less nutritious, it might be easier to catch a bunch of them than to catch one of the alternative option. Demographics matter here too, right? Certain prey might have an older demographic, might skew older. They might skew to one sex or the other, right? And maybe older animals or female animals or male animals or young year animals, whatever, are easier to catch. And so you might sort of actively go for those sorts of individuals. Sometimes we see specializations with the predator, right? So we think about certain animals like fishers, right, that are, well, they're specialized on fish. So they might be, a small mammal, but they're more likely to try to go after a fish instead, right? Competitive exclusion can be a factor. What competitive exclusion is here is where you have two different individuals or two different species. One outcompetes the other and actually literally prevents the other individual or the other species from accessing a resource. So if you have one predator species all by itself, you might go for this thing and do very well. But if you bring species B in there, species B will outcompete them for that resource. Species A will have to pick a different one. We then talk, therefore, about generalist and specialist predators. Most predators, by nature of the beasts, are going to be generalists. They will take whatever they possibly can, right? It does not pay to be particularly choosy if your prey can fight back, right? And so they'll take a wide variety of different things, right? And again, mostly here in terms of what's in front of them, right? If you parade, if you had a squirrel in front of a dog, they'll take the squirrel, right? Even if there's 50 of whatever else that dog might want to eat somewhere else, the squirrel's right in front of them, the dog will take the squirrel. And so choosing between different prey is relative to that availability more than anything else. There are, of course, some specialist predators, right? Okay, and they require their prey, that one main prey item. They can't eat anything else, right? So things like black-footed ferrets, for example, require prairie dogs. They cannot survive without prairie dogs. Lynx cannot survive without snowshoe hare, right? So they while they can and will take other items, that is their primary prey item. That is what they're going to go for exclusively 100% of the time. And finally here, prey vulnerability impacts prey selection and predator success, right? So not only are they going to choose different items based on what's more readily available to them, but also it determines how successful that predator is going to be. Most animal hunts are unsuccessful, right? It's like going fishing. You can sit there for 3 hours and catch one fish, right? A lot of those attempts are going to be unsuccessful. The more vulnerable the prey item is, the more likely that the animal will be successful in that hunt, okay? And so things that play into vulnerability here are going to be age. Very young and very old individuals are more at risk. Some instances here with sex, sometimes females are more at risk here as well. Males might be bigger, more likely to fight back, stuff like that. An ailing or starving individual, if we are in our winter coat and it's summer, right, or a summer coat and it's winter, right, environmental conditions play in there, all kinds of different things. And one of the things that we always need to keep in mind is that the things that we're doing Okay, our management efforts can always, 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 and often always will have unintended consequences. Okay, so from there, we will go on and we will talk about habitat interactions here, and then we'll continue on with this rest of the chat.